Hello and welcome to my presentation of my technology infused unit on Newton's laws. Let's get started. Just for an overview, the lesson was about Newton's laws. We used Gizmo about auto crumple zones, discussed auto crumple zones as part of the lesson. We used that because our final project in the lesson was these egg vehicles, as you see here. These were all made by 8th graders who created these vehicles from a very simple kit of materials, and they created these vehicles to withstand a front-end collision. A little refresher, Newton's first law is that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. In these images, we see an object at rest, we see an object under balanced force, which also means it will stay at rest, and an object under unbalanced forces, and it will start moving and accelerating. Newton's second law involves the relationship between force, mass, and acceleration, typified by this equation: force equals mass times acceleration. We see 4 different balls here, all with different masses. The greater the mass, the less acceleration or velocity that it would end up getting, depending on the amount of time that the force was applied. And then Newton's third law is for every action, there's an equal and opposite reaction, or for every force, there's an equal and opposite force involved. To continue the overview, the lesson involved the following 2 Minnesota 2019 science benchmarks. The first one here, design a solution to a problem involving the motion of 2 colliding objects using Newton's third law. It's pretty obvious that those are our egg vehicles. And then part of a benchmark we worked on in the previous lesson involves just a continuation of the concept that a change in an object's motion depends on the sum of the forces on the object and the mass of the object. Okay, so the technology used in this lesson was a Gizmo. Gizmo is an online library of math and science simulations. And the one we chose for this lesson was called Crumple Zones. This is the front page of the Gizmo. And you can see here that this is the educator view. So you can choose to add a class or launch. And then down here you have extra materials that you can use. I chose to use the student exploration sheets. It had 4 different sheets to pick from depending on which concepts you wanted to teach. There was one on Newton's laws. That's the one we picked and worked with. And let's just take a quick look at what the simulation looked like. So this is the first screen that you see, and you can see that it has 4 different tabs up here at the top: design, crash test, table, and results. And this has already had 1 crash test done, but here we can see how we can design different aspects of the crumple zones on the front of the car, and you can change those characteristics, those variables. And in the beginning, students will be able to just do this freely without any instruction at all, and they can choose whether or not to have the seatbelt or the airbags. And the car is down there at the bottom, and we will see it crash in just 1 second. So as we adjust all these variables, and now you go to the crash test tab and you can choose the velocity that you're going, and it gives you a description of what the experiment is, and then you see the crash test both down at the bottom and in this bigger thing, and we can see that the passenger, the driver, seems to be okay. And then you can look at the data there in the table, and in the results will give you both a graph. You can pick your variables that you want to examine, as well as you can look at other variables. It shows both the car and the dummy, or the crash test dummy, and then you can also see a summary. And one of the big things for middle schoolers is really this: crash results down at the bottom. Dummy hit the airbag, did not hit the steering wheel, no injuries. It didn't always say that. So for instance, let's switch this to 2 cars and make them close to the same in mass, and we will see there that crash did not appear to work quite the same. And as we look at the result down there at the bottom, dummy hit the airbag, death by trauma to head and torso. So not the same result as the previous one. Okay, that was our demo there. Let's move on and talk a little bit more about how this served our educational goals. So, how did the technology support, how did the use of this gizmo support our teaching strategies and best practices? I rank this interactive and amplify on the PICRAT framework. The students explored independently. This fostered hands-on activity type behavior from the students. They later worked in groups on the same interactive, which is a collaborative learning experience. It encourages science talk. It provides instant feedback to students, which is great, so they can quickly see the changes they make, whether or not the dummy lives or dies. And also this provides assessment opportunities. As a teacher, I can walk around and see how the students are working with the interactive and if they understand the concepts that it's showing them. It supported student learning and understanding because it allowed students to explore the concept and build their own knowledge of how Newton's laws explain real-world phenomena. Student engagement was a big hit. This was a really fun interactive for students to work with. They really enjoyed it. How did the technology connect to relevant context and prior knowledge? I think that riding a car is pretty universal for kids in Minnesota, and sadly, I bet that almost all of them have seen some sort of car crash. Hopefully, not too many in person, but they all have TVs. So, this supported digital literacy, mainly just in the fact that students can learn that online simulations can be powerful and quick. This is a really once students get into it, this is a really good interactive that it moves quickly. The simulation doesn't require any time to load up and buffer or anything like that. So, and it supports creative and independent thinking. Students had the ability to explore freely and just try anything out before we gave them a worksheet. So they did that first exploration, and then we gave them a worksheet that gave them a little bit more guidance to learn more about Newton's laws as opposed to engineering, which is one of the other concepts that this gizmo can teach. So a little bit about limitations and barriers. One of the big limitations of using this is it requires a lot of time. It was a challenge to get students into it. It took a little bit of time as a new login. This was an interactive they hadn't used yet, and it was a little bit slow and tedious the first time. The next day, when they went back into it, they all went in very quickly and got in easily, but we lost a significant amount of time the first time. And then as well, the interactive, when you load it up, has some assessment questions as part of the interactive, but you want to kind of avoid those. So you have to for the exploration part of it. So you have to kind of give additional instructions as to where to go to get the interactive to be in the right spot for them to just explore. So barriers, this generally would require one-to-one devices so that every student could do it on their own. And not all schools have that. It's in a lot of schools, so it's probably not too big of a barrier, but it's something to think about. And the cost. I don't know the cost. This is one of those online tools where they provide you the free demo very easily, but then the cost isn't actually listed. So I assume it's probably more of a school purchase rather than something a teacher would get on their own. So possible solutions for those are to do the interactive in groups. It worked really well to do it in groups with the students that we had. They enjoyed talking to each other and trying to figure out different solutions as to how to adjust the variables to see the results. So, and cost, I think that a school could invest in Gizmos. They have a large library, so I think there's probably a lot that teachers could use, and both in science and math. So I think that's great. In conclusion, I would recommend using Gizmos. They take a little bit of time to get used to in the beginning, but I think once your students are used to them, I think they'd really enjoy them. Thank you.